Mr. Clelland here for Clelland Maths. We are on National 5 Maths vectors. So I'm going to go through the whole vectors in National 5 Maths, and a lot of these questions are from maths.scot. It's an excellent revision site, but we've also got our app now, app.clellandmaths.com, where you can go through it question by question by question and get solutions and hints and tips and everything you need. Completely free, just download now at app.clellandmaths.com. Example 1, in the diagram, U, V and W represent vectors A, B, B, C and AC. So remember, there's two ways to talk about vectors. You can talk about it as from one letter to the other, A to B, with an arrow, or we can just name it with a small letter, either in bold or something with a line underneath it. So these are in bold. And we've expressed the journey of V in terms of U and W. So with vectors, it doesn't matter how you get where you're going, as long as you start and end at the same place. So I can directly go from V to go that way, but I can go a different way. I'm starting at B and I'm finishing at C, so I can take it from here and then from there. Well, where have I went? I've went minus U plus W. V is minus U plus W. Why minus U? Because that way is positive U, so if we go the opposite direction, it's minus. And we're done there. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code ClellandMaths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code ClellandMaths. Click the link to order now. Okay, example 2 on vectors. PQRS is a trapezium with RQ equals 2SP. PQ and RQ are represented by vectors U and V. Find R to P in terms of U and V. So let's identify where it wants us to go first. It wants us to go from R to P. Now I could go down there, but I don't know that one. I could go this way and that way, but I don't know that. Or I'd go the direction where I can see. I go along V, then down minus U. V minus U. So for part A, R to P is just V minus U. Okay, part B says find R to S in terms of U and V. So it wants me to go from here to here. Now, we've already went from here to here, so I can get to there straight away by going V minus U. So the question becomes, what is P to S? Well, is there anything in the question that helps us? It says that RQ, here to here, is 2 of SP. Well, that means that if I write this up here, another way to say that is SP is then a half of RQ. So if it's a half of a vector, just a multiple of it, I can write it as half of the letter. So P to S is minus S to P. So if I write S to P that way, we know that's a half RQ, so that's a half V. And now we've got our whole journey. I want to go from R to S, so it's V minus U, then minus a half V because it's the opposite direction. So let me write that down. We had V minus U minus a half V, and then we can simplify that by collecting terms. V minus a half V is just a half V, so that's a half V minus U, and we're done there. Okay, example 3 on vectors. Given that U is minus 4, 5 and V is 3 minus 1, find V's. Well, what is that telling us? What's this minus 4, 5? Let me just draw a picture to the side to just illustrate what a vector is. Remember, it's a place in space, a line. So it's a bit like saying I've went along minus 4 on the x-axis and down 5, and I've got to that point, that coordinate, which would be roughly down there. That coordinate would be minus 4, 5. So the vector from 0, 0 is that. So that's our vector. So that's what minus 4, 5 is. But it doesn't have to be drawn there. It could be drawn anywhere in space. As long as you draw the same direction and same length, it's still minus 4, 5. It goes along minus 4 and down 5. So that's all that says, and that's how we write it with those brackets. Now to add vectors, you can either add them on a diagram, Or in this case, you can just add them directly. You just add the top and add the bottoms. To take away, you just take away the top, take away the bottoms. To multiply, you just times each number by the thing you're multiplying by. So we'll do these ones in turn and you'll see that. A, I want to do U, which is minus 4, 5, plus V, which is 3 minus 1. So I'll just add the top. 4 minus 4 add 3 is minus 1. 5 plus minus 1 is 5 minus 1 is 4. So I get minus 1, 4, and we're done there for part A. Part B says U minus V, so minus 4, 5, take away 3 minus 1. Now watch your signs here. I've got minus 4, take away 3, that's minus 7. And then I've got 5 minus minus 1. Well, that's 5 plus 1, which is 6. So minus 7, 6 is U minus V. Question C, 2U minus 3V. Well, that's 2 times U, which is minus 4, 5, minus 3 times V, which is 3 minus 1. So times in each of the numbers inside by 2. 2 times 4 is minus 8. 2 5s is 10. Take away. 3 times 3 is 9. 3 times minus 1 is minus 3. And now we can do our sum. Minus 8 take away 9 is minus 17. 10 take away 3 is 10 add 3, which is 13. So there's our C. Let's look at D. D says a half U plus V. 1/2 of U plus V. So that's 1/2 of the first vector U, which is minus 4, 5, plus my V, and my V, remember, was 3 minus 1. So I half each of the numbers for the first one. Minus 4 divided by 2 is minus 2. 5 divided by 2 is 2.5. Plus 3 minus 1. Minus 2 add 3 is 1. And 2.5 minus 1 is 1.5. And we're done there. Okay, example 4 in vectors. This time we've got P and Q, and there's 3 numbers. Vectors don't have to be 2D, because remember they are position in space. So if we draw them flat on a bit of paper, it could be 2 dimensions. But if it's just a position in space, then they could be 3 numbers, 3D coordinates. Same idea, we have to find 2p minus q and a half p minus q. So part A, 2p minus q. Well, that's just 2 times the whole of p. 3 minus 2, 1. And then take away q, 5, 0 minus 3. So times in each of the numbers in the first one by 2. That's 6 minus 4 and 2. Take away 5, 0 minus 3. 6 minus 5 is 1. Minus 4 take away nothing is minus 4. And 2 take away 3 is 2 add 3, which is 5. So there's my first answer, 1 minus 4 and 5. B, a half p minus q. Well, p minus q is in brackets, so I'll do that first. So I'll just take the half and write p. 3 minus 2, 1. Minus q, which is 5, 0 minus 3. So that's a half of 3 minus 5, which is minus 2. Minus 2 take away 0 is also minus 2. Then 1 minus minus 3 is 4. So half in each of the numbers, I get minus 1, and 2. And we're done there. Okay, example 5 in vectors. Find bar, bar, v. Bar, bar. The magnitude of v. So what does it mean by the magnitude of v? Well, remember v, a vector we can draw in space. We can start it from 0. And this would go along minus 28 and down 45. So it would be way down there somewhere, but let's just say that is. So our magnitude of our v would go along 45 and down minus 28. So a bit like a coordinate, that would be 45 minus 28. Now, if I was to join that up here and then make a line there, I would have a right angle triangle. Well, how long would each of the bits be? Well, I've went along 45 and I've went down 28. minus 28, but I'll just write 28. We'll put a minus for the sake of clarity, actually, maybe. The magnitude is just the length of a vector. That's all it means by magnitude. When all vectors, unless they're horizontal or vertical, are going to be diagonal lines. And to find the length of a diagonal line, we use Pythagoras. So it's just 45 squared plus 28 squared, or plus minus 28 squared, which is the same thing, and then square rooted. Now, we're not usually going to have to draw a picture to do it, because the numbers are given to you inside the vector, so you just square both numbers and then square root the answer after you've added them. Simple as that. And if it's three numbers with 3D, then you do all three numbers squared and square rooted, because that's like a space diagonal. So let's do this one. The magnitude of V is equal to the square root of 45 squared plus minus 28 squared. Now you can either just drop that minus, or remember to actually put brackets around it, minus 28 in brackets squared, so that it actually squares it properly. 2809 square root 2809 is 53, and that's it. We're done there. Example 6. Find the magnitude of vector r, which is 8, minus 19, and minus 4. So that is just Pythagoras, but 3D Pythagoras. So the magnitude of r is the square root of all the numbers squared added together. Notice I'm putting brackets around my negatives so I don't mess this up. So I get my calculator. I've got 8 squared to do, plus bracket minus 19 squared, or you can just drop the minus, plus bracket minus 4 squared. Well, that's 441. So that means we can square root that. And we get 21, and we're done there. Quite often these come out as whole numbers, by the way, but it could be a decimal answer. Example 7. Find bar a minus b, where express your answer as a surd in its simplest form. So notice with this example, we've not said find the magnitude. You need to realise that those two bars mean find the magnitude, which is Pythagoras. First of all, I need to do a minus b. So a minus b is equal to 5, 6 minus 9, 4, which is 5 minus 9 is minus 4, 6 minus 4 is 2. So that means that the magnitude of a minus b is equal to the square root of minus 4 squared plus 2 squared. That's the square root of, well, 16 plus 4 is 20. Well, that's not a surd in its simplest form. So this is non-calculator. So now we'll just combine the surds. Root 20, remember, is a surd, is root 4, root 5. If you need help, check my surds video, which is 2 root 5. And we're done there. Remember, we're doing regular members-only live streams every single week, only $4.9. Remember, we're doing regular members-only live streams, so get on that if you want some extra help. Just click the link. Okay, example 8 on vectors, still non-calculator. The diagram shows a rectangular base pyramid relative to the coordinate axes. B is the point 860. The apex D is directly above the center of the base. So imagine that's our center, that's where D is. The height of the pyramid is 7. We could take a note of that then. From here to here is 7. I'll just take a note of the side, I think. So our height is 7. We've to find A to C in component form. So we're starting at A, which is out here. And we want to go from C, which is over there. So to get there, I'm going to have to go from 0 along to A, down to B, and along to C. That's one way you could do it. But the other way to remember is that A to C is just the position vector C minus A. So if I know that, if I know C and I know A, I can do it. Now, how do we know C? Well, what's the point B? Point B is 860. So we can take a note of that. That's 8, 6, and 0. So can we find any other points? Well, to find C, always starting at 0. Well, C is not along. So C is 0. I then need to go in the y-axis, but I go in the same amount as for B, so that's 6. And then once I've got there, I don't move, so that's still 0. So C is 0, 6, 0. And what about A? Well, to get A, I go along the bottom, which means I went along 8. And I've already done it. I've not need to move anymore, so it's 0, 0. So for part A, A to C is my C, which as a vector is 0, 6, 0, minus my A, which is 8, 0, 0. That's minus 8. 6 minus 0 is 6, 0 minus 0 is 0. And we're done there. So just a quick note on this one, because your teachers might not teach you this. Why is it C minus A? Well, if I want to go from A to C, I can go from A to O, which is minus A, plus O to C, which is plus C. So it's minus A plus C, or C minus A. And that always works, so that you can always just say it's the second letter minus the first letter. Let's do A to D then. So I want to go from A up to D, so I just do the same trick, D minus A. So if I can work out D and A, I'm good to go. And since you know the coordinate is starting at 0, if the coordinate of the point, say, is 8, 0, 0, then the vector is 8, 0, 0 as well. So D, well, we know it's 7 high, and we know it's in the middle of here. So if I go along to get to here, I need to go along half of there, which is 4. So my D is equal to 4. I then need to go in half the way. Well, half the way is half is 6, which is 3. And then I need to go up the height. Well, the height we know is 7, so that's 7. So it's 4, 3, 7 for D. 4, 3, 7 minus our A. Well, our A is 8, 0, 0. So that gives me minus 4 and 3 and 7. Last part of this question, determine the exact value of bar AD. Well, bar AD for question C is the magnitude. So that's the square root of minus 4 squared plus 3 squared plus 7 squared, which is 16 plus 9 plus 49. 49 plus 9 is 58. 68, 69, 70, 74. The square root is 74. Now, since it says the exact value, it just means as a square root, probably is simplified. Square root of 74 is simplified, so we're done there. It's been National 5 Maths, 2016 Paper 2, question 3 on vectors. The diagram below shows a parallelogram. AB is represented by U, shown in the diagram, and BC is V. We have to express B to D in terms of U and V. So we need to start at B and get to D somehow, but we don't know that one. But we can take any route we want, remember? So we can either go along here and then up there. So what would that one be? The same as that one, because it's the same size and direction. So I'll note that's V. Or you could go along here and along there. And that one would be the same as this one, but the opposite direction. So that direction there would be U. So let me just go this way. Minus U plus V. Done. Minus U plus V. Or you could have written V minus U. Same idea. There you go. SQA National 5 Maths, 2018 Paper 2, question 10. Diagrams below, A to B and E to A represent vectors U and W. As you can see, U and W. It says that E to D is 2 lots of A to B. So this one is double that one. So that means I can immediately write down that this one here is 2U. It also tells me that E to A is 2 lots of C to D. So if E to A is double that one, that means that this one is half of this one. So I can immediately write down that this one is a half of W. It now says express B to C in terms of U and W. So I need to get from B to C. So I could go this way, B to C. But I can't actually, I don't know anything about that. But remember, vector routes means you can just go any direction you want. So I'm just going to start at B and go back all the way around and write up everything I've got. So B to C is equal to, starting at B, I need to go this way, that's minus U, then this way, minus W, then this way, plus 2U, then this way, plus a half W. Simplifying everything else, the U's go together, minus 1U plus 2U is just U, and then minus 1W plus a half W is minus a half W, and we're done there. We'll just put little underlines on it because they are vectors. SQA National 5 Maths 2019, paper 1, question 10, some vectors here. It says in triangle PQR, PR is 6 minus 4 and RQ is minus 1, 8. Express PQ in component form. So P to Q is going from here to here. That is the same as P to R plus R to Q. So writing that out, P to Q equals P to R plus R to Q. So that equals 6 minus 4 plus minus 1, 8, which is equal to 6 minus 1 is 5, minus 4 plus 8 is 4, 5, 4 in component form. Part B, M is the midpoint of PR, express M to Q in component form. So let's find a route for M to Q. We could go from M to P to Q or M to R to Q. Let's go that way. So M to R plus R to Q. So we could say that M to Q equals M to R plus R to Q. Now we already know what R to Q is, it's minus 1, 8, so we need to find out what MR is. It should be obvious that M to R is a half of P to R. So we can write that down, that M to R equals a half of P to R, which equals a half of 6 minus 4. So just half in both the numbers, that's 3 minus 2. And therefore M to Q equals our 3 minus 2 plus our R to Q, which is minus 1, 8, which equals 3 minus 1 is 2, minus 2 add 8 is 6. 2 to 6 is our final answer. Okay, example 12 on vectors. SQA National 5 Maths 2021 paper 2 question 5 had this one. U and V are shown in the diagram, find U minus V. Now when I'm doing vectors and taking away, if I'm doing it on a diagram, I don't want to think about taking away a vector, I just want to think about adding vectors. So I'm thinking about doing U plus minus V. Now what is minus V? It is just this vector, but in the opposite direction. So starting here and going that way is minus V. And when you add vectors, you do your first one, and then you add your other one on to the end. So I'm going to be going that way because I'm going in the opposite direction. So let me just do that then. So minus V, well, if you think about it, it goes along 1, 2, 3. So I'll go along 1, 2, 3, and then I go up 1, 2, 3, 4, 1, 2, 3, 4, and we just draw a nice neat line in between there. So that's minus V going that way. Added them together. So now to find the vector U minus V, it's just whatever vector it is going starting at U and going there, because that's U minus V, so that's the other way to get there. What is the answer to that? We'll just count. I'm starting here and I want to end there, so I'll go along 1, 2, and I go up 1, 2, 3, 4, 5, 6, so it must be 2, 6. Let me write that as our answer. And then the other way you can do it is just do it with numbers. So let's start off, do it with numbers just to make sure that we can do it both ways. If we're going to do U minus V, then we can just write down U minus V. Well, what is U? It's starting here, because it goes to there. 1, 2, 3, 4, 5 along and 2 up. 5, 2. Minus V, well, I'm just looking at my normal V now. I always start and then end. So I'll go along 1, 2, 3, and down 1, 2, 3, 4. So it's 3 along to the right, so it's positive, and then down is minus 4. 5 minus 3 is 2, 4, 2 minus 4 is 6. You get the same answer, and we're done there. Okay, SQA National 5 Maths, 2021 paper 2, question 17 on vectors. Triangle ABC is shown. A to B equals U, it shows that in the diagram. A to C equals T. And G is the point such that CG is a third of CB. So if I knew this whole one, then from here to here would be a third of that, and from here to here would be 2/3 of it. Okay? We have to find A to G in terms of U and T. So we have to go from A to G. So let's see if there's a way we can get there. Well, first, this is quite a tricky question. First of all, I will need to know what C to B is, because I'm going to have to go kind of down there. I can't go along there directly. So I need to go along and up, or I need to go along and down. So it's not telling us this, but we do need to know CB or BC. So let's do CB. Well, CB is equal to, starting at C, minus T plus U to get back to B. So I'm just going to write that, minus T plus U, or you can write U minus T if you prefer. Now we can go, because I'm just going to write A to B then, A to G then. Well, I start at A and I go along C, say, that's T, plus, and then I'm going along this one, so it's something to do with T minus U, minus T add U, and it's just what fraction is it, because it's the whole line is minus T add U, but it does tell me that CG is a third of that, so that's a third of that, so plus a third, and there you go. And I just need to expand and simplify. T minus a third T plus a third U. 1 minus a third is 2/3, so that's 2/3 of T plus a third U. And we're done there. SBA National 5 Maths 2024, Paper 1, Question 4. A is 3, 4 minus 1, B is 5, 3, 2. Find 3A plus B. Okay, so 3A plus B. So I need to times A by 3. 3 3s is 9. 3 4s is 12. 3 1s is 3, so it's minus 3. Plus B, which is 5, 3, 2. So being careful, 9 plus 5 is 14. 12 plus 3 is 15. And minus 3 plus 2 is minus 1. And we're done there. SQA National 5 Maths 2025, Paper 1, Question 13. P and Q have these components, 5, 2 and 1 minus 3. Draw P plus Q. Well, I'm just going to work out P plus Q first. P plus Q, I just add the top, 5 plus 1 is 6, and then 2 plus minus 3, or 2 minus 3 is minus 1. So I need to draw 6 minus 1. So I just pick somewhere on my grid, and I go along 6, 1, 2, 3, 4, 5, 6, and then I go up, no, down 1 because it's minus 1. So I'm starting there and ending there, and you should use a ruler, get a straight line, and draw an arrow. So that's P plus Q there. Let's just double check that. Starting here, 1, 2, 3, 4, 5, 6. 6 to the right, and then down 1. So we're done there. SQA National 5 Maths 2025, Paper 2, Question 15. In the diagram below, DG and GE are R and S, and they're shown in the diagram. But it also says that DE is 3EF. So in other words, here to here is 3 of here to here. I have to go from G to F. I need to go there. Now I can't go that direction, so I could go up here, but then I'll need to know that one. Or I could do some funky thing like go up here and go all the way along, but I still need to know that one. So I'm going to have to work out D to E in some way, or E to F. So I'm going to do D to E. To work out D to E, I could do a journey of starting at D. I could go down R, and then I could go up S. So we know that that's R plus S. So D to E is R plus S. And we know that E to F is a third of that, because D to E is 3 of E to F. So E to F is a third of D to E. And now I can find my G to F. G to F is just going to be starting at G. I need to get to F, so I can go up S, plus along here, which is E to F, a third R plus S. expand the bracket, S plus a third R plus a third S. S plus a third S is 4/3 S, say, plus a third R. And we're done there. This is Mr. Clelland from Clelland Maths today. We've done the whole of vectors in National 5 Maths. Quite a tricky little topic, so if you need any further help, make sure you get on our members only live streams. Take care, stay safe, and goodbye.